Okay, all right. Continue. Get all 6 of your models laying on this piece of paper. Read those descriptions about. Don't be looking at your minerals yet. Just deal with your models. We'll do the minerals later. Just look at the models. Get them laying on that sheet of paper.
That's what I was just gonna say.
Not in your but not in here. So we don't have their presentation. I'm gonna get somebody to share with you.
This one. Okay, yeah.
There's 3 things, then you look at the ones that
They just look up, they're looking inside the box. Yeah, that's good.
unless it's that
How many dimensions is it pushed in?
That could be.
I know, I've been there 2 months. He said, look,
No, that process made.
okay.
Yeah. Read your definitions, link to axes and angles.
I love that degree that the plan that they had. So one of those integrated No, 3.
And these aren't because this is less than 90, then that has to be more than 90 because it's a linear pair. I don't know. So then there's 1. There's the other ones are.
All right, y'all have them on there?
But anytime you have one acute, you must have one opportunity where that would make it.
Perpendicular to the plane.
Two oblique angles. But these do have the 90 degrees.
Well, we know for sure that those all 3 entities are different.
You're talking about the link inside.
Inside the box, inside the plastic.
That's where you decide to hold on.
That's right.
These are supposed to be all in one.
And those.
So we're definite about those.
I'm sorry. Math? Yes.
Right, so that would be 3.
Sandy?
We're good with this. So we're kind of going down.
Y'all may have it.
So an obtuse angle is less than,
But this is definitely like, this is a wrong.
The 90 for sure. I'm totally guessing.
This is just a cube that's been switched over to the side. This is definitely a rubber. So that's going by that word right there. I would say it should be. Just because, yeah.
This has all three.
What about you?
all right, I need to see some finished pages. Okay, you're great. Finished with those squished ones.
How they want them.
Y'all finished? Let me check. I think so.
It's our final answer. Whether it's right or not.
Okay, do you see this definition? 3 unequal axes all at 90-degree angles? That's not right. All right, y'all can put them in the tray. Y'all can put yours in the tray. Okay?
Where's the key at?
Because we had it that way.
Okay, now where you can, the definitions, just so you can see.
Okay, so these were all. She's an absolute teacher. No, this one's down.
But only in style.
This only has two.
That's why
All right, I need your attention, please. All right, I am seeing your models correctly positioned, and so if you will put those in the tray and give your attention to Miss Browning, Mrs. Browning, Dr. Browning,
I'm gonna say Mrs.
Mix Browning.
I want to look at these shapes. I want to look at y'all's if y'all don't mind. Thank you so much. So this shape, what did y'all say about the angles and the sides and everything of this shape? What was your description?
Cubic so 3 equal axes at right angles or 90 degrees.
Okay, 3 equal axes at right angles or 90 degrees. So in mathematics, Tim, we call this a cube. Because all of the faces are congruent and it's all 90-degree angles for the vertices. But it's also 90-degree angles for the axes. Okay? So in math, we don't usually talk about the axes of the shapes. So it's good to know that a cube has perpendicular axes no matter which two you look at. Okay? Perpendicular meaning what? 90 degrees. They form 90 degrees. Okay? This is half of my lesson this afternoon, so you're ahead of the game. All right, don't want to get them mixed up. So, you science people, what was your, or anybody, what was your description of this one? Orthorhombic, and why is that?
3 unequal axes, 90 degrees.
3 unequal axes, meaning what, science people? Not the same length from where to where? From edge to edge?
Yes.
End of the crystal to end of the crystal?
Right.
So 3 unequal axes, however they meet at 90 degrees, they're all perpendicular, okay? In mathematics, we would call this a, who am I gonna pick on? Okay, go ahead.
Rectangular prism.
Rectangular prism. To be a prism, it has to have two parallel and congruent faces. And to be rectangular prism, the two parallel and congruent faces have to be rectangular. On this one, we could count these as the bases. We could count these as the bases. We could count these as the bases, because these two are parallel and congruent and rectangular. These two are parallel and congruent and rectangular. These two are parallel and congruent and rectangular. So it's a box. Okay. What did y'all call it? Rectangular prism for math. Rhombic crystal.
What is the prefix ortho mean? What is it mean? What's the meaning behind ortho?
I know what it means in math.
It has to do with.
Yeah, but just in the shape.
Okay, in medicine, it has to do with the bones, because Christopher's going to an orthopedic surgeon. So I'm expecting this to be the, I know where it is. I'm expecting it to be, kind of the bones of the shape.
Okay, it means, ortho means straight, rectangular, or upright, so an orthodontist is making your teeth. Then chemistry, it denotes the substitution at two adjacent carbon atoms. So, I don't know.
We'll talk about straight.
We like straight.
Because that shape is straight as compared to leaning, which we're gonna get to. Okay, so what did y'all call this in science? Hexagonal crystal, good, because in mathematics, this is a hexagonal prism.
Uh-oh, wait.
She's on this one.
Oh, you're on, okay, I'm sorry.
We can tell, thank you.
6, yes. So in math, this is a hexagonal prism. Why hexagonal?
Bases are hexagons.
The bases are hexagonal, or they're hexagons. Remember, the bases have to be parallel and congruent. So the hexagons are the bases, and then rectangular lateral faces. The bases of a prism can be almost any shape that's polygonal. Can't be circular, but polygonal. But the faces of every prism, the lateral faces, are rectangular. So what about the angles here? The axes, I'm sorry.
They're equal. They're equal.
Okay, 3 equal axes. Where would those axes be? The way I'm holding it, they're horizontal. Then you said an important word, horizontal to the bases.
Okay.
So those axes are congruent, are equal, okay? And parallel to the bases. Because this is a regular hexagon. Okay, all the sides are the same length. All right. But the vertical axis here is not, it's not congruent. Maybe longer, maybe shorter, is that right, Patty? Always longer, always longer here, the vertical axis. Always longer than the 3, horizontal ones. And the angles that they form inside are all the same, they're congruent, and that angle is, I heard you say it, 60 degrees. Now, you math people, where else does 60 degrees come in with a hexagonal prism?
Regular, irregular.
Not you can.
You said math people.
But you're sitting at the back table.
She's the GT one. Dr. Browning, isn't it the angles of the
interior angles or the exterior angles?
interior?
The interior angle. Sure.
36.
Okay. Okay. This one. It's kind of leaning. So what kind of shape is this? This face is a parallelogram, right? And the parallelogram is like a rectangle that kind of leans. Okay? Rectangles are also parallelograms, they just don't lean. But usually in a book, when you see a parallelogram, it leans. Okay? So this side's a parallelogram, this side's a parallelogram. I can't tell about the other two. But what is this called in science? Monoclinic crystal. Where does the mono come from?
One, one axis of different length, or it is leaning in one dimension, because the triclinic is leaning in 3 dimensions.
Okay, so it's leaning in one dimension. So these two are parallelograms, and I'm assuming these two aren't. Okay, leaning, all right? So the axes, tell me about the axes. They're unequal, all three. And, okay, she said a word we need to talk about, 2 oblique axes. In mathematics, you're talking about the angles, right?
Yes.
In mathematics, we do not have oblique angles. We have right angles, and I believe y'all have right angles as well. And we have acute angles, which are what type of angle, Donna?
Angles that are less than 90 degrees.
Thank you. And we have obtuse angles, which are what kind of angle, John? Greater than 90 but less than 180. Greater than 90 but less than 180. So Kim, thank you Kim, looked it up, and when they say the word obtuse angle in science, they mean it is just not a right angle.
Oblique.
What did I say?
Obtuse.
All right, when they say the word oblique in science, thank you, they just mean not a right angle. So if an angle in here is acute or obtuse, they call it oblique. Okay? So that needs to go in the dictionary.
So I looked up the definition of monoclinic.
Okay?
And monoclinic is of or denoting a crystal system or 3-dimensional geometric arrangement having 3 unequal axes, of which one is at right angles to the other 2.
One is at right angles.
One is at a right angle to the other 2 axes.
This one says
Well,
that
because it
third
says,
axis
with third axis, yeah, perpendicular to the plane. Perpendicular wouldn't that imply that there's no right angle?
perpendicular would be the right
It's the right
angle.
angle.
That was the right one.
So these two are perpendicular.
Yes.
Yeah, you're right.
All right.
It's not to
Can we go on? Everybody straight so far?
All right. Is that what they're talking about?
Have I already done this one? Need those squishy ones.
You need this one.
This one? Okay, what did y'all call this one? I thought I did this one.
Yes.
The check. Okay, I did this one already. So what is the difference in this one and this one in science? Size?
Yeah, the 2 equal axes.
Unequal axes.
Okay. This one has how many equal axes? None. This one has how many equal axes?
2.
2, and that is the difference. And these axes form what kind of angles? 90 degrees, so they're perpendicular, as well as this one. So the only difference is the congruency of the axes.
And what makes the axes congruent in the one on the left, on Sandra's left? What is making those 2 axes congruent?
doesn't have the oblique.
There's something about the shape.
It's not oblique, and
Squares.
this face and this face are both squares. Whereas this one had no square faces, they were all rectangular. Well, the square is a rectangle, but they were non-square rectangles. Whereas this one has, thank you, Kim.
So does that one have a different name?
She asked a good question. We said in math this is called a rectangular prism. In math this is called a rectangular prism. Yeah.
Just a different type.
Just a different shape, size. And this last one, what is the name of it? Triclinic. Tri means 3, so if I could have your attention, please. Okay, tri means 3. 3 what?
Unequal axes.
Unequal axes. You can almost guess that now that I'm learning this, because it is oblique, right? And what about the axes?
Yeah, all obliques, they're none at right angles.
None of them are right angles, they are all in science oblique, or in math, they're either acute or obtuse. Which one are they? Both, I see both in there. Okay. Okay. What, this is called what, Tim, in math? You know it.
Come on, Tim.
Some of the faces are parallelograms. If it were straight, it would be a prism. So it's leaning. What do we call a leaning prism? It's oblique. It's an oblique prism. So it's kind of like science. It's an oblique prism, not an oblique angle. Because we have oblique shapes, we don't have oblique angles. Very confusing for dictionary people. So we have oblique shapes, but we don't have oblique angles. And we all have oblique angles that form shapes to be oblique in math. Okay? Questions about this? Ashley, are you the,
Alicia,
Alicia, I know her name.
with the I, this is Alicia with the Y.
Which one is the dictionary person? Okay, did you get all that? Yes, I did. All right, great. Okay, so I have one more quick question. Patty keeps calling these axes. In mathematics, where are our axes? On a what? On a graph, right? A coordinate plane, we have X and Y. But in 3D, when you get to high school, you have X, Y, and Z, which gives you the three-dimensional shape. So when she says axes, they're the same as in mathematics. And there's three axes. Because we're in the real world in science. In mathematics, we're kind of fortunate, we get to create our own little perfect little world. But in science, they have to deal with the real world. Okay? Any questions about all that? That was fun.
That was great.
Thank you.
That's called team teaching right there. Okay, and so, do you suspect that most of your mineral samples will have a perfect, definite, identifiable crystal shape?
Negative.
Could you tell me why they probably don't?
Because they're natural.
And so those perfect crystal shapes are rather rare, and they cost a lot.
Yeah.
Okay, so if you're out hunting, you're more apt to find a massive sample. So look at your notes on crystal shape, and it says, warning, do not try to make every one of your samples fit a perfect shape. You might see some evidence, you might see enough evidence to tell me its shape, but if you don't, you write the word massive. Do you see that word in your notes? All right, underline it. Now back to mineral number 1. Can you
Wait a minute.
identify its shape?
What does massive mean?
I'm sorry?
What does massive mean?
Massive means no identifiable. The crystals just didn't have space or time to form one of these 6 perfect
Doesn't fit no
shapes.
shapes, so you can't identify
You
the
can't
shape.
identify it. That's what it means.
So that's not what it means in math, so there's another word.
What does massive mean?
Just like in the